We have the reaction at A and the pin at B. What we want to do is, since we know how to solve this if we had point loads, I can draw my free body diagram, at least my external free body diagram for now, in a simplified version of how this distributed load is happening. So I have my beam. And at A, I have that roller. And at B, I have a pin. What I want to do is simplify this distributed load and draw it on this free body diagram as a point load, or I could break it into multiple point loads, and that would be okay also. It's a triangle from A to the 6 feet from A, and then it's just a rectangle after that. So what I can do is I can treat it as two different shapes. So I'll start by the easier one. It's going to be the rectangle. We see that the intensity of the rectangle is 150 pounds per foot. So we can treat that like the height of the rectangle, 150 pounds per foot, and its base, it's 8 feet long that we're applying this load. So if we find the area of the rectangle, it's 150 pounds per foot times 8 feet, the area of that shape will give us the equivalent weight or the equivalent force due to just the rectangle. So what we get is 150 pounds per foot times 8 feet is 1,200 pounds. The first thing is, how much is it? And right, we have to see where to place it. Because it's a rectangle, like we saw before, its placement will be at half of its base. So it's 4 feet from B, which is also going to be 4 feet from this line where that triangular region ends. So it's a 1,200 pound force located 4 feet from B. So that's the equivalent point load. If we took that entire distributed load and placed it at one location, that's where we can put it, and that's how much it should be. That's equivalent externally to that distributed load happening. Again, think of it, if this were snow, if I gathered up all the snow and put it 4 feet from B and put it in a big cylinder, that would be, the pin would think it's the same thing happening as when the snow was distributed across it. Now I have that triangle shape also that I can simplify to a point load as well. In this case, it has a height of the 150 pounds per foot. It linearly increases over 6 feet. So just like a triangle we saw before, its area or its equivalent force will be 1/2 of its base of 6 feet times its height of 150 pounds per foot. So 6 over 2 is going to give us 3 feet times 150 pounds per foot is 450 pounds. Is the equivalent force due to that distributed load. And like the triangles we saw before, its centroid, or where we can put that, is going to be 1/3 of its base away from where the right angle is. The right angle is located on this dashed line I added. So I can say it's going to be 1/3 of the 6, or 2 feet from that line, which is the same as saying it's 4 feet from A. So that's the location I can put this equivalent point load of 450 pounds, 4 feet to the left of A, which is to say 2 feet from where the right angle of that triangle was. So I took the distributed load, and in this case, I broke it down into 2 point loads. For this class, it's fine if you do 2 or if you do multiple point loads. I think in the book they try to get you to reduce it to a single point load, which makes the free body equation step a little bit easier. It's just fewer things to write. But for me, this is fine. 2 point loads is still easier to deal with than treating it as the distributed load. And now this, with a coordinate system, is our complete free body diagram for the system. Now that it looks like our familiar free body diagram, I can solve for my 3 unknowns, the reactions at A and B, the same way that we've done it in the past. So if I take the sum of moments around B, since we have a pin there, I'll have a moment due to the point load of the rectangular section. and I said that was located 4 feet away from B. I'll have a moment due to the triangular load of 450 pounds. And that's going to be 4, 4, and 2, 10 feet from B, minus 14 times A. So I'm going to get A is 664 pounds. In the x direction, I just have Bx. And finally, in the y direction, I'll have my A plus my By minus the 450 minus the 1200. So for By, I'll get 986 pounds.